Okay, so good morning everyone, Senan this side, and in this video we are going to solve this count subproblems, sub-islands. So what you're given is given two m cross n binary matrices, meaning it has only zeros or ones. An island is a group of ones connected four directions. Okay, so any two ones are connected if they are up, down, left or right basically. Any cells outside of the grid are considered water cells. An island in grid 2 is considered a sub-island. Make sure this sub-island, if there is an island in grid 1, contains all the cells that make up this island in grid 2. So return the number of islands in grid 2 that are considered sub-island. So if you see this in this test case, these red ones, right, if you see this red ones, if you take this shape and just place it here, it completely overlaps an island in grid 1. You can see that, you can see this and this island and this island. If you place it here, completely overlaps this island. Okay, so this island completely covers this sub island. This island completely includes this sub island. Now if you see the test case 2, you see this part and this part are same for both the islands, but this is not considered a sub island because these elements that you see, basically this element and this element, are water in grid 1. So these cannot be a sub island. This is definitely an island in this grid, but not a sub island of the grid 1. So how do you actually proceed with this? So for doing this, you should understand this is a graph problem, right? Breadth first search or depth first search, you need something like that. Okay, so I assume you would know the breadth first search or the depth first search algorithm, and what you would do is treat all these elements or all these row and column as the element, a particular row and column, as a node in that tree basically. So what you would do is you would have to find an island in this, and at the same time you need to check there is an island that contains this whole island in itself in grid 1. Basically that's what you're going to do. And similarly you should reject this island because this pie shaped island is not present in this grid 1. So before we get on with the solution, I assume that you know how to count the number of islands in a matrix using breadth first search or depth first search. If you know that, this question is more or less straightforward, and I'll definitely give you the explanation, but let's look at my notebook first. Okay, this is just a small toy example that what I want to show you. You see this, this is grid 2, and you see this L-shaped, right? This L-shaped island is contained totally inside this maybe Z-shaped island. So this L-shaped island is this exists in this grid 1 as well. Similarly, if you see, so I see that the counter I would have, and I would increment that counter. Also in the C, you have this island and this island in the bottom. But if you notice, although these two nodes are basically overlapping, this node is connected with this one, and in turn this is connected with these two elements. There is water in grid 1 at this location, so this cannot be a sub island. Definitely it is an island in grid 2, but not a sub island of grid 1. Now what the approach would be to do the normal first search, and I would keep a global count as 0, and a boolean variable is valid, and initialize this with true. Okay, now basically I would do is I would go here and do the normal DFS traversal as we do. So I see here this is 0, so I don't do the DFS here. I go here, I again don't do the DFS here. I start with this, right, and I mark this node as visited. At the same time, I check if this is a proper land node in the in grid 1. So this is a land node, so I'm good to go. I check, I do the proper DFS. So I go here, I mark this as visited, and I check if this is 1, right? Now I go and check this one as well. Basically we are doing the depth first search traversal, and since I see this, I see this is a valid land in grid 1. And now I've completed the DFS traversal in this one, and see, since my is valid is currently true, what I would do is I would change this counter to 1. Okay, now what I would do is I would check this. Since visited, I don't do DFS here. Since visited, I don't do DFS here. This is a water node, I don't do DFS here, so this out. I go here, I check this is a water node. I don't do DFS here. I see this is a land node already visited, so I don't do this anymore. I go ahead, I see this is what this is a water node, so I don't do DFS here. I see a land node, right? Now this is where the tricky part is. I see the land node, right? And what I do is, first of all, I mark this as visited, but I see, is this one or not? So this is not one. So whenever I encounter a case where this is the grid 2 is land but grid 1 is water, what I would do is basically update this is valid to false, but at the same time I would continue the DFS stuff. So I would go here again, check this with this one, and I would go again here, I would check with this one. So in this case, this considered it to be valid, but because of this, my is valid is false. I have completed the DFS traversal for this one, and since is valid is false, I don't increment here. I keep the counter as it is. Okay, now again I go and check out this one. This is 0, so we don't do DFS. This is 0, we don't do DFS. This is 0, we don't do DFS. We go here, we see a 1, but it is visited, so we don't perform DFS here. We see here it's a land node, but this is visited, so we don't do DFS here. And similarly for the remaining zeros, we don't do DFS here as well. So you see the count is 1 in this case. So this is the whole logic. So whenever you're counting the islands in, basically you need to count the islands in grid 2, and at the same time every element that you check, you compare that if there is a 1 in the corresponding grid 1 location. If not, change the is valid to false. Basically you don't increment the counter. That is the whole point and logic. And let's look at the code in C++. Okay, so as you can see, since the DFS call would take a lot of arguments, right? What I did, I created maybe a different name for vector of vector int, and I said to call this as VVI, and I call vector int as VI. Just renaming of the data type, because if I write vector of vector int here, here, and here, this would be quite big, right? So just for the explanation, I just use this typedef command to do this. Now let's count sub island. So I initialize the global count as 0. Global meaning basically globally in this function, like the scope is within this function. So I get the number of rows and columns, and I created a visited matrix, initialized it with 0, and I say that is valid sub island, right? I initialize this, I declare this variable term. I did not initialize it. Okay, so what I do is, for I go to all the elements or all the nodes, and I check if it is not visited and it is a valid land node. That means it has a value of grid I of j has a value of 1, and in that case I initialize this is valid sub island true, because I assume that this island that I'm going to check is true. So now I call this DFS on this, and if at some point while DFS traversal encounters a node which is a land node in grid 2 and a water node in grid 1, right, in that case it will make this is valid as false. So if is valid is false, I don't increment the count, but if I in no way reached a node that is a land in this and a water in this, I increase the counter by 1, and in the end I return the counter. And now let's check how the DFS code looks like. So clearly, since there is we can go in 4 directionally, right? We can go 4 directionally. So I am just, rather than using a for loop, I just manually gave the commands. So first of all, I get the rows and columns exactly as I did in the count sub islands function, and now check if first I check if it is a valid node or not. So if row and column is either less than 0 or greater than equal to m and n respectively, so that means we are at a node which is not in the matrix in itself. So if that is the case, I just return. Otherwise, if this all conditions are false, that means we are at a node that is inside the matrix. So I check if that is visited or not. So again, if it is already visited, I don't do DFS traversal there. So in that case, again I return. But now let's say if it is, this is all false, that means it is not visited. Okay, so first of all, this row and column represents a valid location in the matrix, as well as it is not visited, and it is a water node again. So grid 2 can have water, right? So if it is a water node, in that case as well, I return. So if we reach after this ninth line, that means we are at a valid index. We are at a node that has 1 in grid 2 and it is not visited. So I mark that as visited, and I say that if grid row and column of grid 1 That means if this same location in grid 1 a water node, I say this is valid is false, right? Note these all are passed reference, passed with reference, passed with reference, and passed with. So that is this. I return it as false. Now I check all the neighboring nodes 4 directionally, and I don't do anything else. So yep, if you do this, this would be working extremely well. Accepted, and see the output is also accepted. So yep, that was the whole video all about. It was quite straightforward if you knew how to do the count islands part. So counting sub islands is simpler than that. So yep, that was the whole video. Hope I was able to explain this to you. Yep, definitely this requires a prerequisite of knowing how to do BFS and DFS in a matrix, assuming that to be the nodes of the graph, right? Now yeah, let's do the time and space complexity. So you see this, basically we are calling this n times m. So time complexity for this two for loops is n times n, and this DFS call throughout the journey, right? Throughout, I won't be doing n square in each and every iteration. Throughout the journey of this whole code, DFS could be called for the worst case all the nodes, right? So n square. So n squared, big of n square plus big of n square, not multiplied, because DFS call would be throughout the journey, right? Throughout the journey, I could travel the whole matrix. So n square plus n square, big O of n square is still the time complexity. What is the space complexity? Space complexity is this n times n again, because we have a visited array, and since we are doing DFS, so the call stack, recursion call stack would have, in the worst case, big O of n square elements. So time and space complexity is both big O of n square. Now the distribution could be different, big O of n square in this for the stack space, recursion stack space. For this is for storing the visited location of any node, and the time complexity is big O of n square for this two for loops plus big O of n square for this DFS in the worst. And otherwise we are good to go. And yep, that was the video, and thanks for watching.